We're starting a new unit. The unit is on energy, but before we talk about energy, we need to talk about something called work. Okay. Work is the intermediate step between something that isn't moving to something that is moving. So, how does that energy become energy? Okay. So, when a force acts upon an object, causing it to move, then that force has done work. Okay. So it if you're pushing on something and it doesn't move, there's no work. If you push on something and it moves, even in the slightest, there's work. Okay. Then you've done work on that object. Um, Work only applies for the part of the force that's in the same plane as the movement. In other words, if the box is moving to the right, and the force is being applied diagonally, or at an angle, only the component of the force in the direction that the box is moving um, does work. So you have to account for only that part. In this case, it's still a vector because it's still a force. And so you would, in this case, use cosine theta. Remember that if you're going to use cosine, then the angle has to be between the force and the movement, the direction of the movement. If the angle is given up by the y, then no, that's not the right angle. Okay. The units of work are joules, not the kind that you wear. Joules is the person that kind of discovered energy. And so the units of work are joules, Joules. Okay. And we use a capital J. Okay. And then work is equal to force times the distance, right? The force of the applied to the object, the distance that it moves. Okay. And then when it's at an angle, we can add that cosine of theta, assuming that it's moving in the x plane. Okay. Here's an example. You're pulling a box with a rope that makes a 45-degree angle with a force of 76 newtons. The box moves 12.7 meters. Determine how much work was done on the box. Okay. So using our guess method, we identify our givens, right? So our force, right? It says right here, force of is 76 newtons. The distance that the box travels is 12.7 meters. And then up here it says that the rope makes a 45-degree angle. That's our theta. Okay. What is our unknown? In this case, it's work. It says determine how much work is done. Our equation is work equals force times distance times the cosine of theta. Okay. And so I have work equals, and then I have 76.0 for the force. I like to put the cosine with the force rather than with the distance. So cosine of 45, and then times the distance, which is 12.7. Multiply all those together, you get 683 joules. Okay. It is pretty normal for work to have a large number. Okay. All right. So to sum it up, when a force acts upon an object causing it to move, then that force has done work. Work only applies for the part of the force in the same plane or direction as the movement, and the units of work are joules. Remembering that work is equal to force times distance times whatever the angle is, or, the cosine of the angle. The cosine part is just the vector part, so keep that in mind. Okay?